All right, last day of class. Maybe I should get some lecture notes to go over. Let's see. We finished balancing redox equations. Everyone comfortable with that? There will be a question on the final on that. Let's look at. Okay. So last class we talked about balancing redox equations. Do we have to know that for the final? Yes or no? Yes, we should. Okay. So practice that. It will be a regular question, not a extra credit. Everybody except for Friday Lab has gotten the review sheet, right? You guys look at that? I'm gonna base my final on that. Okay, so the length, the format for the most part will be like the final exam review that you got in lab this week. Um, there will be some multiple choice, some short answer. You do not need a Scantron for this final. You will have still multiple choice. You will clearly circle the answer. You will show your work for all of these problems and stuff like that. Okay? Everyone comfortable with that? Um, just as a so we didn't finish the last two things from this semester that are electrochemistry. It's kind of cool, but it's not that cool. So I talked to someone who was doing some construction, and we were talking about how difficult it is to like kind of be able to do electricity. And he said that someone told him to just think of electricity like water flowing, and it makes it easier for you to realize that the electrons have to flow in a like a current. And if you break that, like if you put a little stoppage in water, the water's not going to keep flowing. Same thing with electricity, right? Anybody ever do like Christmas lights? And I think nowadays Christmas lights aren't like this anymore. But back in the day, you used to have Christmas lights where if one of them was loose or one of them was broken, the whole light would go out because since electricity is a circuit flowing, if one of those lights were out, the circuit couldn't flow through it and it would stop. They've since then like changed it to where you don't have to manually check each little individual Christmas light to do that. And at this day and age, should we be wasting electricity on Christmas lights? What's our thoughts on that? Yes, you should be happy, right? If it makes you feel happy, maybe. Um, so with these redox reactions that we're learning about, what a redox reaction is one thing is gaining electrons, another thing is losing electrons. We talked about that in detail on Wednesday. Okay. Um, if you can get it so what happens is some reactions are spontaneous, some are not spontaneous. We could look at that, but basically how a battery works is it's the flow of electrons, okay? There's something called a cathode and an anode. Just so you know, I don't plan on putting this on the final exam, okay? Maybe I'll draw a picture. Nah, I probably won't put any of this on the final exam since we're just learning it today. So like this next 10 or 15 minutes, I just want to describe to you how batteries work and things like that. If you are interested in it, you could go on and study it more on your own. It's not really going to be on the test, so if you want to just close your eyes and cover your ears to not do that, then that's fine too, okay? Because this will not be on the final, but it is important to notice, okay? So if you have two different solutions and you have something called a cathode and an anode, has anybody ever heard those terms before? Cathodes and anodes. So that's kind of like with batteries, right? Do we know how a battery has a positive and a negative? And do you know that if we put a battery into like a remote control, it tells you which direction to put the batteries in, right? So just on Monday, my son like got all excited and dropped the remote and the batteries came out and he put the batteries in wrong. And then my daughter went to use the remote and she's like, "Oh, the remote's broken." I'm like, "I don't think it's broken. I think your brother just put the batteries in backwards and she flipped them around and it worked." So what happens is If you put in something backwards, then the electricity can't flow through it in the proper direction, and that's why the remote control is not working and stuff like that. We talked about how if you've watched Breaking Bad, Walter White recharges the battery by taking the chemicals that he was using and putting some wires, because if you put it in the proper direction where it's spontaneous for the electrons to flow, as those electrons flow through the battery, it recharges the battery. Okay, that's how rechargeable batteries and things work. There's certain things that are batteries that are not rechargeable. There are certain batteries that are rechargeable, right? Typically, rechargeable batteries are more expensive. Luckily for us, cell phones have rechargeable batteries. We learned that, eventually your battery life gets worse and worse as time goes on. But in general, if we just think of regular batteries, right? Most of us probably use disposable batteries. Just so we all know, we should not be throwing regular batteries in the regular trash. Do we all know that? You should have a little container where you put all of your batteries. And then how do you dispose of those batteries? Anybody know? Is that the proper place? Probably not. But that's probably the worst possible place. But if we know what not to do, maybe we can know what to do, right? So what is the next best place to recycle those batteries? Anybody? You all just throw them in the trash and just push that down the line. Be like, I'm gonna be alive only for another 60 to 80 years. So who cares that these batteries are gonna be polluting the earth 150 years from now? That's for my grandkids and their kids to worry about. Do we think of things in that aspect? Yes, some people do, right? How should you dispose of your batteries? Any thoughts? Emerson? Okay, well, we should not do that, okay? And you want to know what I do with it? I bring it to campus because there's a bunch of places to put stuff on campus where you can put recycled batteries. If you ever have to go to the dump, there's places to take things that are like disposable batteries, old chemicals and things like that. You also shouldn't be putting chemicals in your trash. If it's a small amount, it's probably not the end of the world. But if all 1 million people in the county do it, guess what? A lot of little problems turn into a big problem. Okay. So think about how you dispose of your stuff. A lot of places have free recycling for things like used oil, batteries, chemicals. You know why they have it for free? I mean, some places try and charge you, but what's our thought? If someone's like, oh, you want me to pay $50 to get rid of this battery? What's the alternative to that? Not paying and disposing of it improperly. So they're like, you know what? We'll let you dispose of it for free. And, things like car oil, if you were to change your car's oil, it would be a lot cheaper. Nowadays, though, cars, it's too hard to even open the front hood. So they make it impossible to do that kind of things like that. So realize that. But take home message, you should just have a little area where you collect all your batteries and then look around campus. And if you don't know where to take them, you can drop them off in my office and I'll dispose of them. Okay. That goes for the rest of your college career and beyond. Mainly because I know I'll just find a place to dispose of it on campus to get rid of it. Okay. But that's one thing. So, how do these batteries work? If we were to, so in one direction, it's spontaneous, right? If it's spontaneous, the electrons will flow. What will happen is you will see accumulation of what. So in this case, we have a copper solution, copper 2 plus, and we put in a zinc strip. And then we have a zinc 2 plus solution, and you put in a copper strip. And what happens is the electrons flow in depending on something called where is it? Let's see. So this is all kinds of stuff about so you can see in a proper battery, we have an oxidation occurring and a reduction occurring, right? These are the half reactions. This is the way you would denote drawing a battery. I'm not going to have you learn about that. The one thing we would have learned about if we would have done the normal last lab instead of the instead of the practice exam. I felt like practicing for the exam was more important than doing an experiment that is usually confusing anyway, right? So do we all agree, if we look at an analogy, if we have two tubs, one with a bunch of water and one with a little bit of water, and we open up a little valve in between, is the water spontaneously going to flow from here to there? Do we all agree with that? Right? So it will not spontaneously flow in this direction, right? That's not going to happen. Well, the same thing happens based on the what's called the potentials of the different chemicals. Okay? So what happens is the electrons want to flow if it's going to go in a downhill direction. If we reverse it, it does not want to flow in the other direction. So as I said, if we needed to charge our car battery and we had some random chemicals because we were making drugs or something or doing any, like, why else would you have chemicals in your car, right? But if you had to like figure out a way, let's say you were in the middle of the forest in a cabin because it's an apocalypse and you want to like make some electricity, if you connect the battery in a certain direction, one direction will cause the electrons to flow, the other direction will not. If you try one way and you're not getting electron flow, switch the cathode and the anode into the opposite solution and it should work. There is actually this table here that could help us understand how to do this. This is called a table of half potential reduction, half potentials. And basically, you would want it to go. So these are all what we call reduction half potentials. For any redox reaction, you would want one reduction and one oxidation. So you need one thing in this direction and the other thing in the opposite direction. Like I said, I'm not even going to go over how to solve for it. But basically, if we had another week, I would go over all of this. And all you would do is you separate the reactions into half reactions. You look up the standard potentials. You take the reduction and you leave it in the value on the table. The oxidation, it's showing you the reduction. So if you're doing an oxidation, you would have to flip the sign. So in this case, we're flipping the sign of this one. If it gives us a positive voltage, that means it's spontaneous and it would cause electron flow. Okay. You're not going to need to solve this, but the way that you would do these kind of problems. So in the homework, let's go to the homework. Okay. So there is an extra credit assignment. Let's see. Oh, so we do have a quiz today. Okay. Let me preview the quiz for us. It's not available till 11:30. It's available from 11:30 to 11:59. The question is, what did you like about this class? Must be submitted by 11:59 for full credit. You can write anything you want in here and you'll get the full 5 points. If you submit it after 11:59, maybe you'll get 4 points. If you submit it tomorrow or next week, maybe you only get 3 points. But this is just a booster to our quiz scores for those of you who would like it. If you want to make yourself be more pressure, go ahead and take a 0 on this so you feel more pressure to do well on your final exam, okay? Or pretend you got a 0 and get the 5 points and still give yourself that pressure, okay? So does everybody in here have the ability to do this by 11:59? No, AM. So you have 9 minutes after class, okay? And I will stop class 5 minutes early for you to go and write in this question and be like, oh, I loved that I could never come to class because the teacher records everything and zooms it and lets me be what I like to call a slacker, but you're not really a slacker, okay? When I say that, that's a term of endearment, meaning that you like to focus your energy on other things in life, right? So we do have a quiz today. You have till 11:59 in the AM. So feel free to do it right now. It's not even available right now. Don't get on your phone and try and do it, okay? It'll be available in about 15 minutes, but at 11:45, you could write in here. What should we write in here? Abby? If you just wrote Abby, you submit the quiz. When I do it, if it's before 11:59 a.m., you get full credit. Abby, if you do that, that's like, you ever heard of Icarus? You know who Icarus is? What did he do? I don't know. He flew too close to the sun, if that's the right person. So if you put your own name, that's just like tooting yourself on the thing, but I'd still give you full credit. So when I go in and give this, I'd give you full credit. So really, this is just a quiz to help you out. Any questions on the quiz? Jack, you got it? Very good. Okay. I mean, I would like to know also if you want to tell me what you didn't like about the class, that would also be beneficial too. Also, they have these things called SETIs. Anybody ever fill those out? You know, you're allowed to like fill out comments, and I probably won't read them for 3 years, but then maybe I will get some feedback on them. But, you know, sometimes I do read them and I take them with a grain of salt because usually the only people who write them are the lovers and the haters, and the ones in the middle don't say anything. So, haters gonna hate. You know what Taylor Swift said? Shake it off. You would think I have a little daughter or something, right? This is gonna be a terrible class, okay? Just so you know, okay? I'm like so sad that this is the last day that I get to see all of your sweet faces besides the fire. You know what I'm really happy about is to see this class semi-full for an exam for once, okay? So the exam is on Wednesday at 10:30. I'll probably come in a little bit early. The exam is written as a 1 hour exam, so you should have the 2 hours should be more than enough time to take that exam. Okay. You were allowed 2 pages of notes. Somebody had to go and remind me about that, Justice, but luckily I forgot to count. So I'm going to assume we had 60 students here. I heard some people were emailing students to come to class just to not show up themselves. Very good work there. Okay. Do as I say, not as I do. That is a very important concept in life. Okay. So when you're a parent, that's what you can say. You know, my son's always like, how come I have to do this and you don't? I'm like, because you're a kid and I can stay up late. Okay. So that's just the way it is. Sometimes you just have to deal with that in life. All right. So we have a quiz today. That's pretty much all I want to talk to you about standard potential. Like I said, if you're doing the homework, let's go back to the homework. For the extra credit homework, let's see. Come on, internet. So I just opened up all of this stuff for practice material. I'm sorry I didn't do it earlier. The exam, so fall 24, last day of class. We're not in fall. Last week of lab review worksheet. In here, the final exam review from spring 25. This is what you got in lab. So in a perfect world, you would be able to do all of these problems in 1 hour, but you will have 2 hours to do it. Okay, so this is taking forever. So let me just find the files on my computer. But basically, I also have the solutions here. Try and do the tests without the solutions, then double check your work, okay? If it gets to Wednesday morning, it's 9 a.m., you're like, crap, I have 1 hour to study. Maybe then you would just only look at the exam with the solution. So these things are not working out, but it should work out when you download them. For this class, let's see what those things are final exam review worksheet for lab. So this is what we did for lab, right? Is this the one? Spring 23? No, that's a different one. So there's some extra ones on here. Let's see. Final exam review for, I think it's at the top. Let's see. What do we have? I have so many old exams for this class. Final exam review. What is it? Spring 25? Spring 25? No. No. Take home exam. If you haven't done the take home exam, submit that. What the hell? Maybe it is just on the desktop. That's why. Here it is. Here's the worksheet key. All right. So it has these multiple answers. I heard some people were complaining to the lab professor that multiple of these things could have multiple answers. Let me give you a little hint. Okay. When you go to do a problem and there's instructions for the problem, what you should do is read the problem and the instructions. See how it says circle each of the following combinations that would make a buffer when equal volumes of each solution is combined. More than one may be a buffer solution. So can there be more than one? Yes, there is. If this was a Scantron test, there couldn't be more than one. But are we doing a non-Scantron test? Yes, we are. So expect this to be the length of the test. It's not going to be exactly like sometimes I just like switch the problem out exactly. There will be a buffer problem. So what makes a buffer as a review? You guys want to review or you just want to end early and get this finals week started off on the right foot? Valerie, what do you think? Really? You want to? Let's party. Okay. I thought it was a potluck. I brought ice water. What did everyone else bring? Kidding. You know, I used to have potlucks with my classes at the end of every semester, but that's in a cool, just kidding. That was at the JC where we had lab and lecture combined. So we'd have big potlucks. Maybe in the future I'll do that, but you know, I don't really want to have microwave popcorn from everyone living in the dorm. So this was at the JC and we had like crazy kind of stuff. Part of that, we should do that at the beginning of the semester, right? So if you want to put that on the quiz, suggestions on what would make the class better, you think if we had a big potluck at the beginning of class, people would start to know each other better and study together more? You think studying together with other people is beneficial for a class like chemistry? What do you think? Is it a necessity? No. But will it help if you get together with people and talk about the actual material and things? Talk about how you think about things? The answer is probably yes, okay? So if you're kind of a person who kind of sticks to yourself, that's completely fine. I'm not telling you you have to go and do that, but in the long run, it might be beneficial to like get to know people, get some contact information. I would say get the number of other people, but I'm sure nobody uses phone numbers anymore. They use whatever kind of cool, trendy app that you use nowadays to DM people, et cetera, et cetera. I don't know any of that crap. Okay. But if there was like a quiz today and you missed class and it was due at 11:59 for a full credit, wouldn't it be nice if your friend Bailey texted you and said, "Hey, make sure you do the quiz today"? Did you text anyone, Bailey? Hater. Anybody text anybody to tell them we have a quiz today? Raise your hand if you did. You're so nice. Very good. You did, Emily? Or you told that's why Emily came to class. She was late for that. That's why Merve just walked in. All right. So if you know a teacher gives things like credit for turning something in on time and you're not here, wouldn't it be nice to let someone know? So if you know someone in class who's not here, feel free to send them a message to get them that free 5 points. Anything that anybody is missing can still be turned in. Okay, everybody understand that? If I haven't made that clear, anything that's missing can still be turned in. You will not get full credit for it, but any credit is better than no credit. Okay, even if it's a F, a 5 out of 10 is much, much better than a 0 out of 10. Do I have to teach you how averages work? It's not a math class. I'm not going to do that. Okay. So how do we know if something's a buffer? Valerie, you said you wanted to review this. You really needed a yerba mate for the last class. The joy of learning wasn't enough. Okay. By the way, if you don't go to the cafeteria, it's $5 today. I've already gone once, and I probably will go after class again. So Valerie, how can you tell if something's a buffer? So it needs to have a conjugate of something, but what does the main thing have to be? Kayla? It has to be a weak acid and its conjugate base, or a weak base and its conjugate acid. Now, I'm noticing here that I have a HF, 2 molar HF with 1 molar NaOH, and it says equal volumes of each of these, okay? NaOH. What is HF? Bryce. Very good. And what is sodium hydroxide, Bronson? So why would I circle a weak acid with a strong base as when we just said, Kayla just said it had to be a weak acid with its conjugate base. Can anybody explain to me, is this a typo on my answer key? In which case that'd be messed up, right? Anyone have an explanation? Ian? Any thoughts? Why did I circle 2 molar hydrofluoric acid with 1 molar sodium hydroxide? Why did I circle a weak acid with a strong base and say that it's a buffer? Loot, any thoughts? No thoughts. Okay, good. Jackson, which means what? Okay, and then what happens? Very good. Justice, buffers. The reason it's a buffer is because of buffers. My favorite thing when I was a student, when I didn't know an answer, I would just take the question and I would reword it and make it super redundant and hope the teacher didn't read it enough. And they're like, oh, yeah, this person wrote 2 sentences. It sounds like they did that. So for me, you think I read your answers when you write a question? What do you think? Yes, heck yes, I do. Okay. But if it's homework, I don't look at all your homework. Okay. You could submit something that was a Declaration of Independence. And as long as I see you submitted it on time, I'm going to give you full credit for the homework. Okay. For the ones that aren't like submit the answer and get answers. So some things I will not look at. That is 100% true. But do you think doing the actual homework is going to help you more than just putting in fluff? Yes, you can get 100% on the homework and still fail all the exams and still not be successful. Okay. So I give you the answer key. You could copy the answer key word for word and you'll still get full credit for the homework. Is it going to help you for the exam? Writing the answers will help you at least know what the answers should kind of look like. It's better than not doing any homework, okay? So those of us who don't do homework, if there's a rate law question and I say write the rate law and you have no idea what a rate law even is, you won't even know to write rate equals K times something, right? But if you copied the answers out of the homework and you copied the answer rate equals K times A times B, maybe then like, shoot, I have no idea how to tell. And I give you the thing, right? When A doubles, the rate doubles, therefore first order. When B doubles, the rate also doubles, therefore first order. So this is the correct answer. But if you just copied the answers from the homework, at least you could get some partial credit on the exam because you're putting an answer that's within the possibility of the answers versus someone else who said, oh, what's the rate law? 7. That's not the rate law, right? But I mean, 7 is better than no answer. But writing rate equals K times A, maybe that's wrong, but you're going to get, over half the points because you're showing me the right rate law, even though that's the wrong answer. That makes sense? So seeing what the answer should be at least makes it look like you have some semblance of an understanding of what we're going over. Yes, Jackson. Okay. Yeah. Well, so it's not about acidic, right? So you're on the right track, right? The OH minus, there's half as much OH minus as the HF, right? If this OH minus goes and deprotonates half of those HFs, you still have 1/2 of HF remaining, and the other half that got deprotonated becomes the what? Conjugate base of that weak acid. So as long as I'm giving you less of the base, so just like how we use stoichiometry to determine the ratio in the Henderson-Hasselbalch, remember that stuff from the take-home exam? By the way, excellent job on the take-home exam. I'm so surprised everybody did so well on a take-home exam. It's like you all just harnessed all of the energy of the world and know how to do that. Did anybody cheat? I'm not going to call anyone out on it. Okay. But you know when I'm going to know? When you get that same exact question on the final exam. Look at this question on the final exam over here. Titration problem. Is there going to be a titration problem on the final exam? What's your guess, Luke? This is your last class of college, Luke? Okay. So as a seasoned veteran of the college career, if a teacher gives you a practice exam like this, do you think what's the possibility that there's a titration problem on this final exam? Pretty high, very good. He didn't say 100% because, maybe then I would have like switched it out on him. But I'd say there's like a 98% chance that there's a titration problem on this test. Do you need to know about the stoichiometry of, like what Jackson said, the OH minus reacts with the weak acid? It makes water, but it makes the conjugate. Now it increases the conjugate base. It reduces the weak acid. And now we know the ratio and we can use the Henderson-Hasselbalch. Remember all of that stuff? Should I go and throw a wrench and give us a titration problem with a weak base and a strong acid? You think we could all solve that? Do we think some of us could solve it within that 2-hour time period? So maybe next year, if I give a take home, I'll do that since we have an unlimited amount of time and to see, can all these people do it? What did you all think of the take home exam? You all hated it? You would rather just get it done in 15 minutes and be done, or do you like having the unlimited amount of time? Thoughts? Let me know on the quiz answer today, okay? Anything you want to say to me, it is a completely anonymous thing other than it being submitted in your name, okay? But other than that, it's completely anonymous, okay? I don't see names when I'm grading tests and things like that, okay? I actually grade one page at a time, so I know whose test it is on the first page, but after that, I don't look at people because I'd be like, oh, I like this person. I'm gonna give them 4 points partial credit. Oh, I hate this person. Actually, I don't hate anyone, okay? The people who I don't know you, okay? And, if you wanna get to know the teachers, you come in. You know what was weird? How many office hours did I have this semester? How many weeks has this semester been? 15 times 2+ office hours a week. So I had like 30 to 40 office hours. And you know how many people came to office hours? One hand covers it all. Okay, one whole hand. You know how many students are in here? 107 on paper. I would say probably only like 90 something are left. It's a pretty good retention rate, I think. But in general, that is a time to go talk to the teacher. You can get things. I will be around on Monday and Tuesday a little bit, okay? I would say when people come in to talk to me about the final, it is never a bad thing. I might tell you like, I wouldn't study that because I'm not putting it on there and you know what not to do. But I'm not saying you have to come in. So I think I only have office hours on Tuesday formally. But if you stop by my office on Monday, I'll probably be around at some point working on the test. I haven't written the exam yet, okay? Like I said, I'm going to base it on this. Let me tell you some guarantees on this test. There is guaranteed a titration problem. There is guaranteed a Le Chatelier problem, okay? For Le Chatelier's principle, I think it's one of the coolest questions that there can be. What, if you had to tell someone a hint about Le Chatelier's principle, what would it be, Jessica? What is not involved in Le Chatelier's principle for equilibrium? And it rhymes with bolids and biquids. So solids and liquids, right? So on the last test, exam 2, everybody says like, oh, I'm adding a reactant. It's going to shift right. If that reactant you're adding is a solid or liquid, does it still shift right? Ida? No, it doesn't, right? So whenever you're doing a Le Chatelier problem, if you see a solid or a liquid, exit out and don't even think about it, okay? So for this problem, X that out. That's why we had no change, stays the same, no change, stays the same, because people don't think about that. 100% chance that there's going to be a Le Chatelier's principle problem, okay? What was the first one? Rate law. I might not do the rate law. I might do the rate law. I feel like we beat it with a dead horse. There's going to be a buffer problem on there. What is this one? You think there'll be any entropy problems? What's the percentage of that, Jack? Very good. That's exactly what I was going to say, Jack. You must come to every class and listen. Very good. Okay, you must come to every class. Maybe not listen, but I appreciate that you come to every class, all right? What about this problem here? Entropy problem, Using summation of products minus summation of reactants. You think that'll be on there, Riley? Probably. Very good. What about a delta G problem using delta G equals H minus T delta S? What do we think about this? Carissa, you think that'll be on there? Good. Do you think you have to know if a reaction's spontaneous or not? Yes or no? Yes. What about, do we need to find at what temperature it changes from spontaneous to non-spontaneous? How do we do that one? Sophia? Nothing? Yes. Set delta G equal to nothing. Very good job. Okay. So you set delta G to nothing, and that's when it flips from spontaneous to non-spontaneous. So then there'll be some multiple choice questions. Like I said, notice how when I write this, I write something like, I not only circle the answer, I give an explanation. The reason I give that explanation is so that you understand the answer. But if you do this and you write this and you think it, but you did it wrong, I can give you more partial points for a multiple choice problem because you're showing me your thought process. So if you said, oh, I'm going to choose argon because it's the heaviest, I would say like, oh, it is supposed to be the heaviest, but actually xenon is heavier. So if this was a 3-point problem, I'd probably give you 2 points versus someone who just circles this and writes nothing might get 0 points. But if you also X something out, I also give 1 point for eliminating choices. Okay. So I think it's always important to eliminate choices at the minimum. Even if you think you know the answer, go ahead and put a couple X's on there just as insurance in case you're wrong. Then you'll still get that 1 point of thought process. You understand what I'm saying? That makes sense. In this one, both of these were possible, so you could have chose either one. No, because it's just what is basic, and both of them are very basic. Okay. If I ask which is more basic, then maybe that would be a good one. But then you'd have to do math. And do you think you should bring a calculator for this last exam? Only if you're not good at doing super hardcore multiplication, division, logarithms, and 10 to the x's in your head. Anybody in here? What is the log of 4.63 times 10 to the negative 5? First person to tell me without a calculator gets nothing. I don't expect anyone to know that. Don't even try. Look at these problems. I'll probably put an intermolecular force question. Which is the strongest intermolecular force? Ion dipole forces. What if I said, what is the strongest intermolecular force in pure substances? Then what would it be, Robert? Yep, hydrogen bonding if it's pure. If it's just the strongest intermolecular force, the reason why this is stronger, but it's not in any pure substances is why we would think of that, all right? Let's see what else. This kind of question I like. Which of these will always be spontaneous at all temperatures? Maybe, or will we always be non-spontaneous? Maybe I'll say which of these will always be spontaneous. Maybe I'll say which one will be spontaneous at high temperatures and not low temperatures. So you have to think about things like that. In that case, you'd want to do like what I did here, delta G equals delta H minus T delta S. So if I said, which situation will always give a spontaneous process at all temperatures? What would we choose for this one over here? Zeus? You're not listening to the answers on your earphones right now? Or are you just wearing that to look like a DJ and look super cool? Both? So what's the answer? Anybody have any thoughts? So first of all, when it's non-spontaneous, delta G is what? We want delta G to be positive. So if we want it to be, what did I say? Spontaneous at all temperatures? That would be delta G is negative, right? If we want it to be spontaneous, we want it to be negative. So what'd you say, Kayla? Delta H has to be negative and delta S has to be positive. Everybody see that a negative minus a positive will always give us a negative. In this one, it was why it's non-spontaneous. A positive minus a negative will always give us a positive. If I said if it only occurs at high temperatures to be spontaneous, you'd have to think about that. Like, what does that go versus that? There, it's in the notes and stuff like that. This extra credit problem will be a regular credit problem. So you will have to do one balancing redox reaction problem. One other thing I wanted to show you about the, oh, it finally popped up. Cool. Let's see. For chapter 18, homework for chapter 18, do the day after the final. It's worth 1 point. So if you don't do it, you'll only get a 0 out of 1. It won't cripple your grade. But if you do get it, I'll give you up to 5 points. I do give you the solutions for all of these problems. So if it's simply just copying the solutions, because we didn't go over a lot of this stuff. So really for this chapter 18 stuff, I really want you to only have to do the, so you won't have to, don't even worry about these problems over here, okay? This shows you how to do it if you wanted to, but that will not help you on the test. Really, to get the full 5 points, all you need to do is number 1 and 2. And really, you can even do number 2. Don't do it in basic solution, just do it all in acidic solution, because that is going to be the question on the final, okay? Balancing in acidic medium. So it's basically like number 1. Really, if you just submit a file with number 1 complete, I'll give you the 5 points. If you just submit a file on time, I'll give you the 1 point. If you don't do anything else, and if you don't submit it, you get a 0 out of 1. Does that make sense? Yes? Good? So, any other questions on the final? Any other stuff you want me to add on here? Anything we're missing? Zaira? Anything that you really like learning that you want me to add to the final? I'm sure your class would love it. Should we add, what was something that was hard? Integrated rate laws? There's no integrated rate laws on this test. Should we add that? Bryce? You don't want that? Huh? I am. Your corner crew is not here, so you have to represent. Ray, should we do integrated rate laws? Yeah. Okay, so I'll add an integrated rate law. Thank Ray, everyone. Ray, tell everyone your address so they can throw eggs. We're not going to add integrated rate laws, okay? Anything else? Any questions on anything before we complete this? So some of us are graduating. Good luck in life. Some of us might be transferring. Good luck getting all the credits. For those of you coming back, we appreciate you. Sonoma State will be here for at least the next 4 years, I imagine. So you don't really have to worry, okay? But, you know, do what you do. I appreciate you all. If I see you around or on campus, I'll say hi. If you hear a random minivan honking at you, it's probably me, not some creeper. It's just me saying, hey, I see you. I remember you. Don't be afraid to say hi. Enjoy life. Enjoy your summer. Start studying now. You do not need to wait till Tuesday night / Wednesday morning to start this stuff. All right? Have a wonderful rest of your lives if I don't see you again besides Wednesday. Or feel free to stop in anytime. Drop off used batteries. Get a cup of noodles if you're dying from starvation and you can't afford it. I have a plethora. The 5 people who come to office hours would know that. Feel free to leave in the middle of the lecture, all of you leavers. You have 5 minutes to complete the quiz plus an extra 9. So do the quiz on Canvas and have a great time. Aloha. Seniors, we're going to miss you so much. Enjoy your life. I mean, I pretend like I miss